All right, and let's take a look at the next problem. So it gives us this circuit and it asks us to determine the current through R3. So current through R3 is going to be this current here, and we'll call that one I3. So looking at our given information, if I is 10 amps, so this here is I, R1 is 10, R2 is 20, R3 is 15, and R4 is 10. And it wants to know what the current through I3 is. So looking at this, let's go ahead and say that all these are in parallel. So they're all in parallel. And since we're splitting up current, this leads us to do a current division. And the equation for current division is going to be I of whatever number it is times R equivalent over R of whatever number it is times I of S. So we know I of S. We know our number. We just don't know what this R equivalent is. So we had to ask ourselves which R parallel are we going to use? Well, if we look at our current here, we see our current's going to come this way, break off, send some that way, break off, send some that way, break off, send some that way, and then do this whole song and dance where it breaks up and meets back up. So it forms I again. So since it's breaking up, this I current is breaking up across all of these resistors. This is going to be our R parallel. We're going to use all of them. So if I write R parallel, this is going to be 1 over 10 plus 1 over 20 plus 1 over 15 plus 1 over 10. And what does that come out to be? This comes out to be 3.1578 ohms. So all we need to do now is break this up, or write this into our equation. So I of 3 is just going to be equal to 3.1578 ohms over 15 ohms times 10 amps. And this will give us 2.105 amps for I3. Okay. And then if we wanted to find, let's say, I1, so I1 right there, all we would have to do is just 3.1578 ohms over 10 times 10 amps. And that looks like it would just be 3.1578 amps for I1. And then so on and so forth. So you just would replace whatever in the denominator with whatever resistor number that is.